All right, so previously we covered the integration operation, and that finished up all the operations that the system can perform. So just to recap, the system will perform just the pass-through of channel 1 and channel 2, the inversion of channel 1 and channel 2, addition of channel 1 plus channel 2, and subtraction of channel 1 minus channel 2, integration of channel 1, and differentiation of channel 1, all in parallel with each other. And so we covered each of those separate operations, and each of them produced an output. And now from here, the system's going to choose which outputs it wants to display onto the computer. So here is how it selects which operation. I'll use another analog mux as shown right here. And basically here is where the inputs from all the different operations come in. So first things first, I'm going to have to load in all those operations that we performed earlier. So this is the channel 1 pass. If you remember, we created this when we did those pass-through operations. So this is channel 1 pass. It looks like that. Okay, looks fine. Look at channel 2. Right, channel 2 pass. All right, that's good. Channel 1 invert. Okay. Channel 2 invert. All right. Summation, or the adding channel 1 plus channel 2. Addition operation. Okay. The subtraction operation. Okay. That. Okay. The selected differentiation. So this was the differentiation select. Looks like that. And then the integration select. So I'm actually going to run the circuit 3 separate times because, like I said earlier, the system will actually output 3 separate signals. So it'll output a signal for channel 1, which will either be channel 1 pass-through or channel 1 invert. They'll output a signal for channel 2, which will either be channel 2 pass-through or channel 2 invert. And then they'll also output a third signal, which will be the selected operation. So first, we're going to just output channel 1 pass-through. So if we look at where channel 1 pass-through is right here, it's set at 0, 0, 0. So I see I set these switches to 0, 0, and 0 right here. Then I go ahead and I run the transient for 1 millisecond. With all zeros, I should get the pass-through signal. All right, excellent. We have the pass-through signal here. It looks inverted now, but it'll be re-inverted again later. So I'll export this out as channel 1 out. All right, so then I will run it and grab channel 2 pass. So channel 2 pass through is going to be 0, 0, 1. So if it's 0, 0, and 1, I'm going to run the transient again. 1 millisecond. All right, looks like that. So it looks like this. We'll just need to export it as channel 2 out. All right, and the selected operation we need to perform is subtraction, because if we wanted to measure the rectified waveform, we need to do probe 1 minus probe 2. So if we look at subtraction, sub is right here. So if this is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. So it'll be 1, 0, 1. So with that, we will now perform the transient a third time, 1 millisecond, just like all the other ones. Again, we'll run through the simulation. The output this time should be the rectified waveform. So it's the rectified waveform, but it's inverted. But don't worry, we'll invert it again at the very end. We'll invert it again. So we just save this, and this is going to be our operation select. Okay. So now with these three outputs, we'll need to check each three of these outputs. Even though there's only one output, there's probably 10 times as many samples. So we'll need to filter each of those outputs. So if I go and look for, there's channel 1 out. Again, it'll be tab delimited. All right, that's good. Quickly scroll down here. Notice how there's about 10 times as many inputs, so I'll have to filter. So here we're going to filter. All right. So with this, there should now be only 500 samples now. So if I save this as text, tab delimited, this is going to be channel 1 output. All right, looks good. Close this one. So now I do the same thing for channel 2 and for operation select. So is channel 2 out? Again, tab delimited. And again, if we scroll down here, 10 times as many samples. So I'll run the macro for filter samples. Yeah, I can replace that. All right, so then we scroll down here. We have like 500 samples now. Save this as another text tab delimited file. This one's going to be channel 2 output. All right. So with that, now we have to do the actual operation select. So let's find that in here. Operation select. So here's the operation select. We will now perform the same thing. We'll filter out for every 10 samples. Run that. Place that. Scroll down here. Notice how we only have 10 times as many. We only have 500 samples again. So then we just save this. Save this as tab delimited. This would be operation output. All right. So with these three signals outputted, we need to convert these signals into something that can be read by the microcontroller and displayed on the computer screen. So in order to do that, we have one more circuit we'll need to run each of these outputs through to convert into something that's readable by the computer.